Hello everyone, you are all welcome to lecture number 1241 and that is in continuation of heterocyclic chemistry and 5-member ring hetero compound that is called Pyrrole. And in the previous lecture I have already discussed a lot of medicinal and physiological importance of Pyrrole and how it is playing the role as a part of blood and carrier of oxygen, all these things. But during that lecture, one spelling mistake happened and many of my students there wanted to clarify that. Actually, when I was discussing that is heterocyclic chemistry, so in topic by mistake, because those two words are very similar, heterocyclic and heterolytic. So somewhere I have written heterolytic, but I checked my lecture and my both lectures, the introduction of heterocyclic chemistry and again the heterocyclic chemistry of Pyrrole is clear. Only on topic it is heterolytic is given. So I explained them that actually sometimes when we are delivering lecture and two words are very similar, and when we are typing just hetero, the word will come and will touch and it will be typed, so because of very quick typing. And even I explained them that here the difference is that in the case of heterocyclic, it is different atom has become the part of either 5-member ring or 6-member ring. But in the case of that is heterolytic, means where unequal breaking of covalent bond. That is the difference in these two. So now here I am going to discuss the isolation and chemical properties of Pyrrole. Actually, Pyrrole is isolated as well as synthesized, but mostly on commercial basis. It is isolated from Dippel's oil. Dippel's oil means deflated bone marrow, and that deflated bone marrow is treated with acid, and since Pyrrole is mild, basic in character, it will form the salt, and again it will be treated with sodium carbonate, and finally the impure Pyrrole, which is isolated from Dippel oil, with the help of fractional distillation, it is purified. So here I have written here isolation from Dippel's oil, the oil obtained from deflated bones containing Pyrrole along with hydrocarbons like pyridine and nitrile. It is shaken with dilute sulfuric acid, that is H2SO4, to remove the pyridine base, and then boiled with sodium carbonate solution to remove nitriles. The separation of Pyrrole in pure form is done by fractional distillation. So second method is Pyrrole is also obtained by heating succinimide with zinc dust, and in this way we will get the Pyrrole. So here the reaction is given. The first one here we are treating with a carbonate solution, and then Pyrrole will be obtained, that is in the form of salt, and then with hydrolysis there will be formation of C4H4NH and KOH will remain in solution. Number 2, Pyrrole may be obtained by distillation of succinimide with zinc dust. So this is your succinimide, and once it is heated in presence of zinc dust, you will get Pyrrole. So actually continuation, that is how we are getting Pyrrole in pure form. from dipylyl, that is deflated bone marrow. So there I have given the reaction, that is potassium salt of Pyrrole, but that reaction was not discussed. So here in continuation of that, after fractional distillation, again this substance is treated with potassium hydroxide, and by treating with potassium hydroxide, this fraction, that is after distillation, will be converted into potassium salt of Pyrrole in solid form, and that solid form, again when it is subjected to steam distillation, that is at 200 degrees centigrade, and then we will get 100% pure Pyrrole. So here in continuation, after fractional distillation, the Pyrrole with hydrocarbon is passing over 100 to 150 degrees centigrade temperature, that is in presence of steam containing Pyrrole, which may be removed by boiling with potassium hydroxide, that is KOH. In this way, solid potassium Pyrrole salt is obtained, on which on steam distillation gives pure Pyrrole. So reaction, that one is given here. This is actually potassium Pyrrole salt. This is in solid form, C4H4NK plus H2O is steam, and then you are going to get C4H4NH, that is your Pyrrole, 5-member heterocyclic containing nitrogen, and you will get potassium hydroxide. Now the fourth method of Pyrrole getting from, that is ammonium mucate, and this is your ammonium mucate. When the ammonium mucate in presence of glycerol as a solvent is heated at 200 degrees centigrade temperature, there will be formation of Pyrrole plus CO2 plus 4H2O and plus ammonia. So in this way we can get the Pyrrole by these methods. So I am going to discuss the properties of Pyrrole. So Pyrrole is in liquid form, and once it is exposed to air, it becomes brown. It has melting point 131 degrees centigrade, and also it is aromatic in character, and it undergoes substitution rather than addition reaction, and it is less soluble in water, but it is highly soluble in organic solvents like ethyl alcohol, acetone, methanol, and it is having pleasant sweet smell, just like chloroform. Once you smell the Pyrrole, you will think that it is chloroform. And the Pyrrole character, that is very important character, that if you see the structure of Pyrrole like this, and where these two electrons which are sitting over nitrogen is playing very important role to make this Pyrrole nucleus aromatic. Pyrrole becomes aromatic because this becomes, they are all delocalized. So 2 pi electrons here, 2 pi electrons here, and 2 electrons are there. So it is forming sextet. So in that case, it will be, if we are writing in regenerative form, the structure will be like this. So it is aromatic in character, and since it is aromatic in character, but at the same time, it is contributing to delocalization inside the 5-member ring. The Pyrrole is weak base. Otherwise, if it would have not become the part of aromatic system, if these two electrons which are belonging to nitrogen would have not been delocalized and become the part of sextet or aromatic character, then the pyrrole would have been very strong base. So sometimes question we are asking, explain why pyrrole is weak base in spite of the fact that pyrrole is containing lone pair of electron with nitrogen. So your answer should be that since that lone pair of two electrons which belong to nitrogen becomes the part of delocalization to make the pyrrole nucleus aromatic in character. So these are all important properties of pyrrole. So now we are going to discuss the properties of pyrrole, very interesting property. The reason is that it is aromatic in nature, in character, and also it contains NH grouping, so that it should have been very strong base, but it is weak base. The reason is that the lone pair of electron of nitrogen becomes the part of delocalization of the ring and become the part of aromatic character of pyrrole ring. So number 5, properties of pyrrole. Pyrrole is colorless, lightly refractive liquid, boiling point 131 degrees centigrade. It has present chloroform type of smell. It rapidly turns brown on exposure to air, and finally it forms a resinous mass. It is less soluble in water, but it is highly soluble in organic solvents like ethyl alcohol, ethyl acetate, chloroform, methanol, acetone, petroleum ether, etc. Number 6, pyrrole, we have conjugated system. That's why I have given this conjugated system. Whenever there is alternate single and double bond, it is called conjugated system. So double, single like that. And then these two electrons which is belonging to nitrogen become the part of a ring delocalization, and because of that the 5-membered pyrrole ring has aromatic character and it undergoes substitution reaction rather than addition reaction. So link directly to NH group, and the NH group activate the ring so that the pyrrole undergoes the usual substitution reaction just like any aromatic compound. The aromatic character of the ring decreases the basic character of the pyrrole compound in spite of the fact that NH grouping is there. Thus pyrrole is weak base. Number 7, when pyrrole is boiled with either metallic potassium or potassium hydroxide, it gives solid salt of potassium, and that is called potassium pyrrole salt. That is C4H4NH plus potassium, and then it will give C4H4NK plus half H2O. So here with this I will stop, and in the next lecture I am going to continue some reactions, very important reactions of pyrrole. So with this, thank you very much for watching the lecture.